Hello everyone, I am Hasani Amanda, and today I'll be presenting our paper, Humanoid Robots in the Family, Adult and Child Perspectives on Domestic Robots. This work was conducted through the Inclusive Interaction Lab at the University of California, Merced, as part of a high school internship. And in this study, we looked at how families perceive humanoid robots in the home, with a specific focus on differences between adults and children within the same household. We were especially interested in how family members think about robot appearance, trust, responsibility, privacy, and social roles. Rather than treating the home as a single user environment, our study looks at the home as a shared space where different people may have different expectations for the same robot. Humanoid robots are expected to become part of our homes in the near future, helping with household chores, providing care, and interacting with family members. As these robots become more common, it is important to understand how different members of a family perceive them and what they expect from them. Most previous research has focused on individuals. However, homes are shared spaces where parents and children often have very different expectations and concerns. Our goal was to understand these differences and discuss what they mean for designing future domestic humanoid robots. Humanoid robots differ from previous home robots, such as robotic vacuum cleaners. Instead of performing a single task, they are designed to move around the home, interact socially, and work alongside family members. Recent commercial platforms such as Neo, Figure 03, and Memo demonstrate that this feature is approaching quickly. In fact, industry reports predict widespread deployment over the next decade. Yet we know surprisingly little about how different members of the same household perceive these robots. Family members may have different roles, responsibilities, and concerns when thinking about the same robot. Understanding these differences is important because acceptance within a family is rarely determined by one person alone. Our questions focused on multiple dimensions of humanoid robot perception. First, we looked at whether and how adults and children differ in their perceptions of robot appearance. Second, we asked how they differ in trust and responsibility. Third, we wanted to identify expectations that families have regarding capabilities, privacy, and control. And finally, we asked families how they perceive the social role of robots within the family. We interviewed 12 participants from 5 families in the United States. The families consisted of parents and children between 10 and 15 years old. Because current humanoid robots are difficult to access, we first showed participants short video demonstrations of several commercial robots performing household and social tasks. These included robots such as Neo, Figure, Walker X, and Amica, along with conversational examples like Sophia and Nadine. After viewing the videos, each family participated in a semi-structured group interview. Parents and children answered questions individually, followed by an open family discussion. All interviews were recorded, transcribed, and analyzed using thematic analysis. Our thematic analysis identified 4 major themes. First was signaling artificiality and expressiveness, where there was a preference for non-human-like appearance and an avoidance of uncanny realism. The second was bounded trust and responsibility allocation, where trust was task-dependent and there were limits on high-stakes tasks. The third was expectations of control, transparency, and reliability, where clear limitations and predictable behavior was preferred, and there was a need for user control and oversight. The fourth was negotiating social roles and emotional boundaries, where robots were viewed more as tools or assistants rather than family, and parents wanted to manage emotional attachment. Across each theme, we observed consistent differences between adults and children. One cross-cutting observation was that safety influenced nearly every discussion, particularly from the adults. Let's begin with appearance. Adults consistently preferred robots that looked clearly like machines. They were uncomfortable with robots becoming too human-like because they worried about confusion, emotional attachment, and safety. Children, however, focused more on emotional expressiveness. They wanted robots that could display emotions and communicate naturally. And interestingly, both adults and children rejected robots that appeared too realistic, although for different reasons. Adults worried about blurred human-machine boundaries, but children simply described them as being creepy. Trust turned out to be highly task-dependent. Adults repeatedly described robots as assistants, not decision makers. One adult summarizes clearly by saying that they would be more comfortable with robots that assist, but not robots that lead. They were comfortable with robots performing chores or helping around the house, but they were reluctant to trust them with childcare, medical decisions, or driving. They were concerned that robots may not have enough judgment in complex or ambiguous situations, especially when their children are involved. Children, however, reasoned differently. They were more willing to trust robots if they believed that the technology had been properly tested or certified beforehand. And so, adults evaluated trust primarily based on risk and responsibility, while children focused more on technical competence. The third theme focused on control and transparency. Adults had detailed expectations for robot governance inside the home. They wanted clear limitations, reliable behavior, manual overrides, privacy controls, and data transparency. One parent emphasized consistency, reliability, and clear limitations, which shows that trust depends not only on what the robot can do, but also knowing what it cannot. Privacy was especially important to adults. They wanted to know what data would be collected, whether audio or video would be recorded, and whether recordings could be disabled or deleted. Children also cared about control, but they described it more concretely. They wanted robots to follow rules, listen to humans, behave predictably, and explain what they were doing. This suggests that robots may need layered interfaces, deeper privacy and oversight tools for adults, and simple explanations, rules, and predictability for children. The fourth theme asked whether the robot would be seen as a tool, friend, or family member. Adults mostly describe robots as tools, assistants, or helpers. They were uncomfortable with treating robots as family members because they worried about children forming emotional attachments or confusing the robot's role with human family relationships. Several parents did not want robots replacing parental authority or emotional bonds. Children, on the other hand, were more open to companion-like relationships. A child described the robot as more like a friend, while still recognizing that it would not be as close as a real family member. This is an important distinction. Children were not necessarily confused about robots being human, but they were more willing to engage with them socially. Both adults and children also agreed that robots should follow strict moral constraints, especially that they should not be able to harm humans. Based on these findings, we have identified several design implications. First, robots should support adaptive expressiveness without increased realism. This means that they should communicate emotions or intentions clearly, but through stylized or symbolic cues that still preserve a visible machine identity. Second, robots should support role-based autonomy and task boundaries. Adults should be able to define what tasks the robots can perform, what tasks require supervision, and what tasks are completely off limits. Third, robots should have layered controls and transparency. Adults may need privacy settings, data controls, logs, and override options, while children may need simple explanations and predictable responses. Finally, robots should have explicit social boundaries. They can be friendly and helpful, but they should not frame themselves as replacements for parents, caregivers, or family members. Overall, these findings point toward the need for an intra-household personalization, where robots adapt to not only individuals, but also to family roles. This is an exploratory study. Thus, our sample only included 5 families, all with relatively similar educational and socioeconomic backgrounds. Participants also based their opinions on video demonstrations rather than long-term interaction with real robots. Future work will involve larger and more diverse families, longitudinal in-home deployments, and adaptive robots capable of personalizing their behavior to different household members. To conclude, this work provides one of the first empirical investigations of how adults and children within the same household perceive domestic humanoid robots. Rather than finding a single family perspective, we found systemic age-related differences. Adults emphasize safety, governance, and responsibility. Children emphasize expressiveness, competence, and interaction. These differences suggest that future humanoid robots should not only be designed for individuals, but for entire families, supporting different expectations, roles, and relationships within the same home. Thank you. Please reach out to us via our social media channels if you have any questions.